Okay, before we dive into today's lesson, I want to do a quick recap of a couple of things that were important from yesterday's lesson. One of the things we did was we built a unit circle, and the primary thing that we did with the unit circle was to be able to evaluate exact values of trig functions that either appear in a unit circle or have coterminal angles that appear in a unit circle. So as a quick, easy example, if you wanted to know the sine of pi over 3 by using a unit circle, you would locate where is pi over 3 on a unit circle. That x-coordinate gives us the cosine. That y-coordinate gives us the sine. So the sine of pi over 3 is root 3 over 2. Now, why that is the case, that was the focus of yesterday's lesson. Now we're just assuming that you already understand why it's the case. Can you use the circle? Now, all other trig functions, the other four trig functions, can be expressed in terms of sine and cosine. So if you want tangent, it's sine divided by cosine. If you want secant, that's the reciprocal of cosine. If you want cosecant, that's the reciprocal of the sine. If you want cotangent, then it's cosine over sine. All right, what we're going to do is extend that idea two different ways. The first way is to incorporate function notation, and then the second thing that's going to be happening is there's going to be some sort of order of operations associated with the evaluation process. So our instructions are, use the following functions to evaluate the expressions below. All answers should be in simplified, rationalized, reduced fraction form. So no decimal approximations from a calculator. So, number one, h of pi over 3. That means we're going to function h, which is right here. The variable gets replaced by a pi over 3. By the definition of this particular function, we're going to evaluate the tangent of pi over 3. Then we're going to take that answer and divide it by 2. So we go to the unit circle. We find pi over 3. Tangent is sine divided by cosine, the y-coordinate over the x-coordinate. That simplifies down to root 3, and that gets divided by 2, and that's your final answer. Okay, f of pi over 6. F is sine of 3x, so it's going to be the sine of 3 times pi over 6, which is the sine of 3 pi over 6, which is the sine of pi over 2. So we go to our unit circle. We find pi over 2. The y-coordinate at that value is 1. The sine of pi over 2 is 1. M of 3 pi over 4. Function m is cosecant squared of x. So it's cosecant of 3 pi over 4 quantity squared. So what we're going to do is we are going to find 3 pi over 4 in a unit circle, which is right here. Cosecant is the reciprocal of sine. So it's the reciprocal of root 2 over 2. The reciprocal of root 2 over 2 is root 2. That value gets squared. Our final answer is just 2. Okay, g of pi over 3. Function g is here. So it's cosine pi over 3 plus pi over 2. Fractional computation, if you need to do that as scrap work off to the side, pi over 3 plus pi over 2 is 5 pi over 6. Okay, not the point of today's lesson. If that's something you need to practice on your own, that's on your own. We're focusing on the bigger picture right here. So we find 5 pi over 6 on a unit circle. The cosine is going to be the x-coordinate at that value. So our final answer is negative root 3 over 2. Okay, number 5, p of pi over 2. Function p is the secant of x over 2, so it's the secant of pi over 2 divided by 2. That's the secant of pi over 4. So we go to the unit circle. Pi over 4 is right here. Secant is the reciprocal of cosine. So the reciprocal of root 2 over 2 is root 2. That's our final answer. Okay, last one of this type. Q of 11 pi over 6. Q is 5 times the cotangent of x, or 5 times, for this particular problem, 11 pi over 6. So on our unit circle, we find 11 pi over 6. Cotangent is cosine over sine. So it's root 3 over 2 divided by negative 1/2. That simplifies down to negative root 3. Then that value gets multiplied by 5. So our final answer is negative 5 root 3. So again, summarizing what we've accomplished for the top half of the page. Yesterday, we just evaluated a single trig function, like what's the sine of pi over 3. Now we took that idea, put it in the context of function notation, and incorporated some order of operations that need to be done in order to get the final answer. A common question when I teach this lesson is, do we have to memorize these functions up top? No, they're just 6 random functions that were made up for the purposes of this particular skill. Very often in this course, throughout the first half of the year, if we're evaluating a trig function, it's part of some larger problem that involves some order of operations. So this is an introduction to knowing how those order of operations fit in with trig functions. Also, much of what you do at the pre-calculus and calculus level is in function notation. It needs to be something you're reasonably confident with. All right, now moving on to the second type of problem. Again, one of the things that we did yesterday was we looked at evaluating something like the sine of pi over 6. Find pi over 6, y-coordinate is 1/2. What we're going to do now is reverse the order of that question. It's now going to look like the sine of what angle is 1/2, which brings us to that first problem on the bottom half of this handout. The sine of what angle is 1/2? Well, there are an infinite number of angles you can take the sine of and get 1/2. Pi over 6 happens to be one of them. Anything coterminal with pi over 6 would also be an answer. The other place where the y-coordinate is 1/2 is over here at 5 pi over 6. So, one thing that is common with these instructions is they're going to give you a specific interval they want the answer in. In our class, the interval that's most common is the 0 to 2 pi. So in that interval of 0 to 2 pi, when is the sine of the angle equal to 1/2? Well, in the 0 to 2 pi, it happens at pi over 6, 5 pi over 6. Now, the typical problem with these guys tends to have 2 answers. It's possible there could be only one. That usually happens when you're dealing with a quadrantal angle. And it's possible that there's no answers, which is always the case in anything you do in math. No solution is always an option. But the typical, normal, everyday type of question, you're expecting 2 answers. Okay, the next one. The cosine, let me slide this up a little bit. Right there, that's good. The cosine of what angle is negative root 2 over 2? So we need to look where on the unit circle is the x-coordinate negative root 2 over 2. It happens here, and it happens here. So we have 2 solutions, 3 pi over 4, 5 pi over 4. Now again, it's 2 solutions in this interval, not 2 solutions, period. Because any angle that's also coterminal with 3 pi over 4 is also a solution to that equation. any angle coterminal with 5 pi over 4 is a solution. We only want the 0 to 2 pi interval, though. All right, next one. The tangent of what angle is root 3 over 3? So when working off the unit circle, the tangent is where is the y-coordinate divided by the x-coordinate, root 3 over 3. Now, after you've done these for a while, you'll know what those answers are without necessarily doing the computation. But for now, it's a little bit of a guess and check. So where on a unit circle, if we take the y-coordinate and divide it by the x-coordinate, do you get root 3 over 3? It happens here. If you take 1/2 and divide it by root 3 over 2, simplify and rationalize that, you get the root 3 over 3. The other place it happens is down here. When you have the same absolute values, they're both negative. When you divide it by the negative, you get the positive. So it happens at pi over 6, and then again at 7 pi over 6. Okay, a couple of things that we can connect back to something we talked about yesterday. The solutions to any one given equation for these basic ones we're working on now have to share the same reference angle, which means they're going to have the same denominators. The other thing we talked about was our all seniors talk constantly. So we're looking for the tangent of what angle is a positive number. So we know tangent is positive in the first and the third quadrant. So that can help us narrow down where we need to look to be finding the solutions. Okay, I marked up that unit circle pretty good. Going to get a fresh one for the next few questions. The sine of what angle is root 2? So starting this process the same way we did the first 3 examples, we'd be looking for where on the unit circle is the y-coordinate of root 2. Well, if you look, nowhere. It doesn't appear. Now there are 2 options. Maybe this thing has a solution, it just can't be obtained from the unit circle. Or maybe it has no solution at all. So what we're going to do to make that final determination is this thing bigger than 1 or is it less than 1? Because the sine of an angle, if we think back to SOHCAHTOA trig, is opposite over hypotenuse. The hypotenuse on the bottom has to be bigger than the numerator or else it's not going to be a triangle. So if you have a problem like this with sine or cosine, if that total value over here is greater than 1, there is no solution. If that was less than 1 but didn't appear on a unit circle, that would be a type of problem we don't know how to solve yet. We're going to get to that sometime next week, I believe. All right. The cosecant of theta is -2. Well, right away, I'm going to use the same strategy that we've used for a bunch of other things. I'm going to rewrite that as the sine of theta is -1/2. That's a much nicer equation to solve. So where on the unit circle is the y-coordinate -1/2? Here and here. 7 pi over 6, 11 pi over 6. Okay, the secant of theta is root 2. That's the reciprocal of cosine. The reciprocal of root 2 is root 2 over 2 after you flip it and rationalize it. So where on the unit circle is the x-coordinate root 2 over 2? Here and here. Pi over 4, 7 pi over 4. Okay, the sine of theta is -1. Where on the unit circle is the y-coordinate -1? It only happens once at 3 pi over 2. And for these problems where there's one solution instead of 2 in that 0 to 2 pi interval, it's usually because it's a quadrantal angle. Okay, slide this so it all fits here. The secant of theta is 1. That's the same as the cosine of theta is 1. Secant and cosine are reciprocals of each other. 1 is its own reciprocal. So where is the x-coordinate 1? Now it happens at 0 and at 2 pi, so this becomes a little bit of a technicality. With this interval here, the 0 is included, but not the 2 pi. So when we answer this, we're only going to put the 0. If that had the little equal sign underneath, then it would include the 2 pi as well, and then 2 pi would be in our solution set. Okay, next one. Cosecant of theta is equal to 0. Well, the reciprocal of cosecant is sine. The reciprocal of 0 is undefined. So, where on the unit circle do we have a y-coordinate that doesn't exist? Well, it exists everywhere. This is a no solution. All right, now this thing is a little bit specific to the little corner of the math world we're in. It's not true for all levels of math, or all areas of math, rather, but in our little trig world, 0 and undefined are reciprocals of each other. The reciprocal of secant is cosine. The reciprocal of undefined is 0. Not always, but for what we do in here. So where on the unit circle is the x-coordinate of 0? That happens in 2 places. Pi over 2, 3 pi over 2. Okay, last one. Cotangent of theta is equal to 0. So where on the unit circle, if we take the cosine and divide it by the sine, or the x and divide it by the y, do we get 0? So the only way we can get 0 by producing a fraction here would be if it's 0 on top and something other than 0 on the bottom. So cosine over sine, or x over y, that would happen, coincidentally enough, the same places as the last solution, pi over 2, 3 pi over 2. All right, just as a where this heads with the equation solving, for now, with what we're doing in our Unit 2, that's as far as this goes, where it's a trig function on the left, number on the right, we can extract the numbers pretty directly from the unit circle. What's going to happen when we hit our Chapter 5 material a little bit later in the year, there's going to be algebra associated with this. There's going to be foiling, there's going to be factoring, there's going to be a lot of other stuff involved. But ultimately, after we do all that additional algebra and other stuff we'll talk about before we get to that point, it comes down to the very last step, answering these guys. So these problems are problems in and of themselves for right here, right now. A little bit later in the course, these guys become very small part of much larger problems. The better you get at these now, the nicer that later for the course becomes. The people that really don't learn this well really struggle when we hit that Chapter 5 stuff. So you're preparing not only for success in the Unit 2 quiz material stuff, you're preparing for success for a few other things later in the course.